Something similar happened to PhD enrollments. So around about 2009, the numbers of PhD registrations also went through the sky. And in this case, the annual growth rate is about 12%. So somebody did something right somewhere. And I'm sure there were also some financial incentives for students to stay on. And I know from my experience in a different environment that industry also at the time, some of them though, came in and say, I've got some money to spend on PhD students. And we look at the demographics of this group of enrolled candidates. The trend is very similar in terms of a smaller percentage of white students and an increasing percentage of black students. Still not where we are or want to be, but the picture has changed dramatically. If we now look at the graduations, similar picture. And here the average time to a degree is about 3 years. In some places in Europe and the United States, it's much longer than that. And if you look at the PhD, time to graduation or time to your degree is about 4.3 years on average. Now, there was a time in the US where if you were a good student and you had a wonderful supervisor, your time to degree was very long because they used all these brilliant young kids as cheap labor. But they got lots of papers out and they got a degree out and they did postdocs and all kind of things. But it's like a synergistic type of relationship that one has with your supervisor. But sometimes I think supervisors take it a little bit too far. It takes too long. And in all our universities, we had to rethink, what does it mean for a master's degree to take 3 years on average and for a PhD to be 4.3 years? It's not efficient use of our time. So we all had to think, don't we overcook these qualifications? But sometimes this is just how long it takes. So it's about critical thinking here. And very similar trends in terms of our demographics of the doctoral graduates. And then in terms of gender, we've not won this battle yet. I don't personally see it as a battle though. You will see that the percentage of women participating in postgraduate studies is no more than about 22 or so percent, which is an indictment to us. But there are many reasons why this happened. I can refer to, for instance, our mining engineering program at WITS, where 45% of the class, undergraduate class, are women. Okay. But I don't see them in the master's classes. Why? Because they've got to go and work and doing all kinds of other things. The group looked into what are some of these reasons, and we had lots of surveys we did. So often it's said lack of adequate funding. I think that's true for every postgraduate student. There are a lot of negative stereotypes, and that starts in our homes, that girls should really not do things like this. So they don't continue to participate. But I thought that has been put behind us, but apparently not so much. Then there are some areas where there is direct discrimination against women in some of these labs and also in our industry. If you go for an interview in certain industries, people are kind of unthinking and not appreciate that every person who's an engineer, whether it's with a bachelor, master's, PhD, whatever it is, will make a contribution to solve very complicated problems. And because of stereotyping, certain types of discrimination that takes place, many people are unthinking, and meaning that they don't see what's in front of them and the value that people can bring. So it's an interesting challenge, and it's up to all of us to ask the question, so please explain that to me. And often these big guys in industry just cannot do that. So we must ask the questions. There are also not enough role models available, and because there are so few women around, they're kind of dispersed across our country. And if you need a role model, it's not easy to actually see one. You can Skype one, you can see others. And those of us who have been here long before many others, we've got a list of people that chat to us. What must I do now? What are the risks? What's happening here? And all I can say is fear not, okay? Because we can do absolutely anything we want to. And then especially in certain cultures, there's this whole question about the black tax, meaning that many undergrads, when they graduate, have got to go and work to support the families they come from. And then, of course, I think the biggest reason, and when there was this big debate, I remember some dude of one engineering institute wrote quite a controversial little paper on why women are not in engineering or maybe should not be there. If one then did some research, you will find in all these European countries and closer to the North Pole, they have similar things that we have. In fact, for us, it's much easier to attract young women into undergraduate studies, and for them, it's not so easy. Their rate of participation of women in their programs are actually quite low. And the simple reason is they've got options. They don't have to become an engineer. They can do anything else they want. And for them and for our students at present, there are many more options. So we need to be clear why we want to attract people to participate in our profession. And I think I speak for sciences here as well. So if I look at the employability, because our industries now have to move to more high-tech, medium and high-tech type of businesses, and we're not quite there yet. Many of them will not hire masters and PhDs graduates because they don't know what to do with us. They believe you're going to be too clever, and your solutions will probably not be implementable, not in their environment. So we lose a lot of these brilliant youngsters to countries overseas, but many of them do come back. But then when they do something really great, we must still say that was a South African. If we have got a much bigger pool and we can get our industries to start working on their higher tech projects, the international firms will also come in because they're looking for local labor. They have to look for local labor. And the labor would then be, if we've got lots and lots of PhDs, masters, and very well qualified technicians and artisans, they will come here. They don't have to go anywhere else. But because of many reasons, at the moment, we're not the perfect place for people wanting to come to. So it's up to us to change their minds. So where are these engineers employed? This is an interesting picture. And if some university sees this, they will infer a lot of very interesting things, which may not be the case. If I look at the green line are industrial engineers, architects, and other of similar kind of systems-oriented nature. The one behind that is mining engineers and metallurgists. The yellow one is chemical engineers. Mechanical engineers are the grey men. It's not that you're grey men. Electrical, electronic, and telecommunications engineers are this orange bit, and then the civil engineers, they are the light blue. If it was back at home, I would say they should have been the grey ones, but then we would not have been able to distinguish because concrete is grey. If we look at this picture in the various industries, and you've got to look at the y-axis, we've got in the agriculture sector very few engineers involved. Mining and quarrying, mostly mining engineers and metallurgists. Then in manufacturing, we get a smithing of almost everybody. In electricity, gas and water supplies, we also have everybody. Construction, almost the whole team except for the chemical engineers, which is rather odd because cement is one of their products and paint and all those other things, and many of the new products we use are chemical outputs. We've got wholesale and retail. Interesting, there are electrical engineers in that. And then we've got transport. Here I would also have thought that there would be more mechanical and civils, but not so much. And then the financial institutions, a lot of engineers. And the last one here is community and social and personal services, which sits over here. So this more or less where engineers are used in various sectors in our country. And if one just look at this, you can see lots of orange. So meaning they need a lot of electrical, electronic and telecommunications type engineers. They also need a lot of mechanical engineers and a lot of civil engineers. But those cannot be the only three disciplines. And you will find that in most of these industries, just like the scientists, people don't stick to what they were always trained to do because they were taught to problem solve. And that's why we find many engineers in this space and more electrical engineers there because of their, I think, their mathematical, shall I say, knowledge and skill. And that kind of problem solving comes to a good use in that specific space. So a lot of opportunities, we must just take it. For the industry, of course, we must educate them why do they need higher level engineers. I don't think Eskom right now will need a PhD engineer, maybe not. We need, but I do think we may need an engineer. A study was done about the supply and demand for these various disciplines, and you will see the green ones. And who of you are colorblind? Usually a lot of scientists and engineers are. So I must be careful what we say. So these bars on the right-hand side, which I perceive to be green, they are of the demand curves. And you'll see that the demand for all the types of engineers are not exactly the same as what be the supply. And then how does the industry deal with that? We can't tell universities close down your chemical engineering because we don't need that anymore. What these individuals will then do, they use their skills to do other things. And all these other things will be useful things for our country. So let me quickly show you about the international benchmarks. If we look at the tertiary education participation, this is something that I think our government has improved a lot over the last while. In 2008, only about 15% of the school leavers were, or that age group, the youth, was participating in higher education, and currently it's up to about 19%. And if we look at a place like South Korea, it is the same. Everybody that finishes school will go into tertiary education. That's just about the thing that people do. And if you look at Brazil, they've doubled their participation. And Mexico, it's more or less stable at about 28%. And China has also doubled their participation over the last 9 years or so, 10 years. So there's something wrong in this picture with us. There's another graph which international audiences love to refer to, and that is in terms of the participation, to find out what is your data in terms of the percentage of all students that you have in the country, what percentage are doctoral students, and how many engineers per million of the population per year are being produced. So I'll just speak slightly to this, and I'll skip some of the other slides. If we look at China, So the percentage of students in tertiary education is about 32% on average. And the doctoral students of that is about 35%, which is quite a lot. And the number of engineering students or graduates per million of the population per year produced is about 1,150. But they've got 1.364 million people, or a billion, so the comma is on the right place, so 1,364. If I look at Korea, so their participation rate is much smaller, but again it's rather consistent, and they work off a much smaller population than China. And one can almost think that there will be enough other people to do many of the other type of tasks. So this could be slightly smaller because you need to service the whole country. But the number of graduates, engineering graduates, is almost 2,000 per million of the population, which is huge. And guess what? We all have Samsung cell phones and many other things. So something they do, right? If I look at Germany, they've got fewer PhD students, which is also a later trend. People go out to work, and I think the competition is quite high in their country. But they have a population of roughly 80 million, and they produce just over 1,100 engineers per million of the population per year. And then I come to us. We only have about 7.8% percentage of all students are engineering students. 7.9% of those are PhD students, and we produce a paltry 265 per million per year of our population. It makes one cringe, but it's an opportunity. So which one will have to address and see what are we going to do about this. And perhaps we need to start thinking broader about what is this engineering that we're really talking about. And this is a topic for another day. This measure is the progression of students to higher degrees. I'm going to leave it to you to go and read in the book. All it tells us in South Africa, the rate of masters or bachelor's to masters kind of conversion is only about 40%. For women from bachelor's to masters, only 11%. So there's something that we must do there. And then the master's to doctoral in total is only about 31%. So if you want to have lots of PhD students, we've got to recruit them from many other places. And there's nothing wrong with that. We may just want to have to fund them. The completion rates mostly is not too bad, but many of our master's programs and the PhDs go on for so long that people lose interest over a while. In our country, the completion rate for engineering doctorals is about 52%, and mostly because people have to start to work, and when they start working, their employers just use up all their time, and there's nothing left for themselves. And the masters is about 77%, which is not a bad idea. It's a good number relatively. But the South African cohort study of all the students apparently is about 53% that complete. It's much better than our undergraduates though. The other one is education system efficiency. Here we can see that we talk about the percentage of academics with doctoral degrees in different countries. And remember, I gave a lot of numbers. There are many more academics employed at those institutions. And on average in our country, it is about 23% over all the sectors. And the number of PhD students per academic is on average about 1.6. In my mind, it just doesn't quite gel, especially if we see how these numbers increased. Maybe they've got small percentages. Just to show this again in one picture. So this is our number of engineering graduates per million population per year. And this is where we sit. Okay. However, we are doing pretty well if we look at the graduations per million of population in South Africa for PhDs, as well as the number of publications per million population per year. And this is such a typical UNESCO type of number. They love to average it out on the whole population. For engineers, it makes sometimes us look really small. But it's in comparison with, say, Brazil, we're more or less on par. We're definitely better than Mexico. But I believe this number is actually quite low, and it has been increasing quite a lot in the last few years. We do not compete with Korea by any imagination. So maybe we need to go and learn from them. So, last few slides. So we've taken all this data and looked at what does it mean for the postgraduate engineering space at all our different universities. So we see that we've got lots of universities, we've got lots of programs. Unfortunately, the majority of the postgraduate students are produced at mainly 3 universities. And we do have a shortage of supervisory capacity. And then, of course, depending on what you do, the toys that we play with is really expensive. The different universities have got structured differently in terms of how they do their research. Some of the universities, especially those mentioned here, UCT, UP, and WITS, it is based on quite a large number of smaller research groups that then work together to produce all the outputs. And if one then could, by some means, consolidate some of them to let them work together, because you'll find here there's fierce competition for certain resources. If we can rather work together, we may be able to do better. And very few inter-institutional work is done. And the good thing is, most of these universities and the engineers specifically are working with industry quite extensively. Okay, so women in engineering, we need to do something about it. But I don't think it is a goal on its own. It is something that we have to do together with a big picture. And one cannot force anybody to do something that may not be in their interest. So it must become a space where people feel free and safe to do and to study and to work. And that I can say for any other profession, actually. Supervisory capacity is something the government has long already recognized and acknowledging, and you will see there are a large number of projects within universities that are trying to address this. So we buy in supervisory capacity, we train up our youngsters, we train them how to do this, but all of this takes time. It's like an avo. A green avo, there's no ways in the world that you can squeeze that to be ripe. We've got lots of partnerships, and I think we are doing quite well, except the highly qualified engineers in our industries. Although the industry supports a lot of the research we do, they do not employ all these people to help them to advance their own status. Some of them do, but mostly not. It's almost like CSI that they help people to do, but we need to re-industrialize our country. That's one of the major things that we lost. We have to take a regional and international global position on what postgraduate engineering is supposed to achieve. And especially what our role is to advance our industrial participation into the high-tech area. And this doesn't only address so-called 4IR, it addresses many other things that we've got huge skills and capacity in, but we're not taking advantage of. So this is a little bit of what's in that report. I do encourage you to go and have a read. There are lots and lots of really good graphs, and yeah, I hope you all train many more engineers and scientists.